Okay, so we are looking at this question. This is 13.2. This is going to be two-way ANOVA. So let's read the question first off, as it says it up there. What affects how often a student attends lab? Does the instructor or the time of day make a bigger difference, or their interaction? And then blah, 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 blah. So you can read it here. The lab instructors are 1 for Elizabeth, 2 for James, 3 for Maria, 4 for Raphael. And the time of day is 1 for afternoon, 2 for evening. So in other words, let me make sense out of this, what we're looking at. This is one student, okay? This student attended 21 labs. They had instructor number 1, which is Elizabeth, and the time of day they went was 1, which means afternoon. The 2 is for evening. So basically, they're trying to figure out the purpose of this question. They're trying to figure out, hey, do students come to the lab more often for certain instructors than other ones? Or does it matter more like if it's afternoon or evening, daytime or night? So suppose the college is trying to figure out what can we do to get more students to come to the stats lab to get the help they need? What's causing students to come or not come? And they're considering 2 variables. That's why this is called two-way ANOVA. You're considering 2 things that might affect whether students come to the lab or not: the instructor and the time of day, and the interaction between the 2. Like, do they come better for certain instructors than other ones? Do they come better in the daytime than the evening, or maybe vice versa? Or is it somehow the interaction between like certain instructors at night or certain instructors at day? What is it? So this whenever we're trying to figure out how something is affected by 2 different factors, this is going to be two-way ANOVA. So this is what you'll need to recognize on the final exam is when you have a problem. Well, you'll see the big old honking table too, but you see a big old table and they're talking about 2 things affecting something. You're going to go, oh, that's that terribly painful, as you'll see, two-way ANOVA. All right, so basically, this student attended the lab 21 times. They had instructor number 1, Elizabeth, and the time they went was daytime. Oops, sorry, my pin's not working there. It was daytime. And then you go on, this person went 23 times. They also had Elizabeth in the daytime. So all these people, and let me erase those for a minute. All these people in this section, 1, 2, 3, 4, 5, 6, all these people had instructor 1 at time when they had Elizabeth in the afternoon. Then notice how it says 6 students in each cell. So the next cell, all these people, 3, 4, 5, 6, all these people had instructor 2 in the afternoon, which is James. And that's how many times they came to the lab during the semester. And then I'll go on to the next page. Here's the rest. The data there's a lot of data. This next section had a different instructor, had these 1, 2, 3, 4, 5, 6 down to here. All these people had instructor 3, whoever that is, in the daytime. And then the last section, these 1, 2, 3, 4, 5, all these 4, down to there, all these 4, they had instructor 4 in the daytime. And then it starts over again. Notice down here. So we got go back to the blue again. So then here, these next 6, 1, 2, 3, 4, 5, 6, they all had instructor 1 again, Elizabeth. And they had her in the evening. So you see how that it becomes time, the time, which is the last column, is now evening. So there's Elizabeth in the evening, and the next one is going to be instructor 2. See all those 2s right there? Instructor 2 in the evening, and the next one is instructor 3 in the evening, and then the final one is instructor 4 in the evening. All right, so anyway, so we got a whole bunch of data. There's 6 students in each group. We have altogether, 8 groups? So we have 48 students. See how if you count all those, see, because it's right, there's 6 here and 6 here and 6 here and 6 here. There's 4 groups and then 4 more groups. right? So 8 times 6, whoops. 8 times 6, 48 students in the various, having different teachers at different either day, afternoon or evening classes. And we're wondering which factors are affecting students coming to lab. Is it the instructor? Does that make the biggest difference? Is that the factor that matters? Is it the time of day? Is it daytime, evening? Or is it an interaction between the two? That's what two-way ANOVA is able to do. All right, so how do we do it? So basically, the first thing we're going to do is we're going to take out our calculator and we're going to put, I'll write the instructions right here. You're going to, on your calculator, your TI, first off, you've got to get the program from me. So you've got to get the two-way ANOVA program, which I give you with my wire. So once you've got that on, this won't work if you don't have the two-way ANOVA program on your calculator, on your TI. So the two-way, it's called A1 ANOVA is what it's called. I mean, you got to have a program. You got to have a special program, which you get from me, which is called A1 ANOVA. And I'll give it to you with a wire. So once you've got that, then we can do this problem. How do we do it? Well, the first thing we're going to do is we're going to hit second and the, the X to the -1 button, which has matrix above it. So we're going to go to the matrix thing. And so when we're on the matrix thing, and I'll show all this in a minute, then you're going to go over twice to edit. And then you're going to go down 3 times to D. This is important. We've never done this before. You got to go down to the little D, the matrix D, and then hit enter. So in other words, you're going to edit matrix D. That's what you're going to do. So let me show that now with my little handy dandy, there. There, you can see that, right? Okay, yeah. So let me show you. Let me actually do it right here. So let me turn my little demonstration calculator on. There it is. Okay. And I'm going to go, oh, and let me, well, I'll just, yeah, here. Let me view the key press history. Yes, I'll put over here. This is going to show the buttons I press. Here we go. I'm going to hit second matrix, which is the X to the -1 that has matrix above it. See that? And then I'm going to go over to edit. See, I'm on the edit menu up here. Now I'm going to go down to D. So I'm on edit D. The program just uses matrix D for whatever reason. And I'm going to hit enter. Boom. And so matrix D is now on the screen saying, matrix D, what size do you want it? Well, I'm going to tell it, remember how many students we had in our list? 48, right? I'm going to tell it I want a 48 and then go over by 3. Enter. 48 by 3. I'll explain why in just a second. Well, you saw our big table, right? Our big table was 48 down and 3 across. So I just told it 48 down by 3 across matrix D. And now just put all that data in the table. Watch out. This was a pain for me, honestly. When I first did it, I kept messing up. So let me save you some time. Use the down button. So for example, go like this. My first one is 21 and hit down instead of enter. If you hit enter, it's going to move sideways. And which is okay, I guess, but it'll be way easier for you just to go straight down because the other columns just have a lot of 1s and 2s. Those are easy to do on their own. This will save you a lot of time and you're going to need to save time. This section is terribly painful with data entry. This is a small one compared to what we're going to do in a bit. So, so just go 21 down arrow. So my point in all that is use the down arrow. Don't use the enter. I kept using the enter and messing up my data and wasted hours of my life. Don't do what I did. See, I'm just hitting down arrow every time. So just put all the data. So go all the way down, put all your data, whatever data you have, straight down that first column, all 48, all the way down. And then go over, when you're all done with that, go over to column number 2. You know, and column number 2 is a lot easier because that's like 6 1s in a row, then 6 2s in a row, right? 1, 1, one, 6 of these in a row, et cetera. And then do the last column. So put all those in. And when you're done, when you put all that data in, you're going to go second, quit, right? Whenever we put the stuff in our calculator, we quit. So let me go back to my main screen and write that out for you. So when you're all done, I'll say put in the data. Put in the data. Oh, wait, I forgot to give the size. No, 48 by 3. 48 by 3. Enter. Enter. And then put in the data. And then hit second. And the mode button, which has quit above it. All right, and so then you'll quit that. So once you put all that data in, you'll quit. So get all that in there. And then that's all let's just call all that step 1 over here. This is all step 1. And then over here, step 2. Once you've got all that in and you've quit, you've done second, quit, you're going to hit the program button, PRGM, the program button, and you're going to choose the A1 ANOVA program, wherever that is on your list of programs, and hit enter. And you got to hit enter usually again. And then you're going to choose number 2 on that program. It does a lot of things called the random block design. Choose that and hit enter again. And when you do, it'll put a bunch of stuff on the screen. I'll just say it's a full screen of info. It's not very clear what you're supposed to do. You're supposed to basically hit enter again. It's giving you this big spiel. You just hit enter again. And when you do, it'll say, do you want to continue? I don't know why it asks a million questions like this, but you just hit enter again and say, yes, I want to continue. And it'll do a bunch of, then you get a bunch of output on your screen. That's what you'll get. So once you go through all that, now let me explain what you're looking for in that data. You are looking for the following. It'll say F of A, and then a p-value. And it'll say F, let me just change the color here. It'll say F of B and a p-value. And then it'll say F of AB and a p-value. So those are the numbers you care about. So like for example, F of A might be, I don't have to make up numbers here, 2.91, and this might be 0.007. And F of B might be 3.76, and this be 0.261. And this be 4.81, and this be 0.439, for example. So it's on this homework question, as you come down, it's going to ask you for these things. Let me see. Let me show you the question here. Let me show you mine real quick. There we go. There's what it's going to ask you about. So those answers we're going to put right here. So these 6 answers, yeah, I'll just write them right here. So this is going to be your f of A and the p-value. And then f of B and the p-value. F of AB and the p-value. So we're going to put those in just like that. And so I'm going to write in what my made up numbers were again. But I'm just going to put in the 2.91.007. Okay. 2.91. And 3.76.2 something, what did I say? 0.261. And then lastly, I had 4.81.439. 4.81.439. Okay, so put those numbers in there. Now, how do we draw a conclusion? What does all this mean? Well, it'll say, what does it say right here? See right here, the fine print, which, if any effects were significant, use significance level 0.05. So which ones are significant? Well, you know how it works. If the P is low, the HO must go. Specifically, it's significant, right? If the P is low, that means there's a low chance of luck, the results are significant. So which of these had a low P-value? Only this one. This one's low, this one's high. Pin's lagging here a little bit. This one's a high P-value, and this one also is a high P-value. So the only P-value I got that was low was this one, and that's what? P-value for instructor. So I'm going to choose main effect for instructor, which means the instructor made a difference. The calculator is telling us in that data presentation that the instructor made a difference. In other words, which instructor you had made you go to lab more or less. That was the factor that affected how many times people went to the lab, at least in my data. Yours might be different. Now you can have, by the way, you can have more than one answer here. Sometimes you'll have 2 of these. You can have, if 2 of your p-values were low, then you would click both the instructor affected it and the time of day affected it. Or maybe the interaction between the 2. Or you could have none. You could choose more than one of these boxes, is my point. It's not just going to be one box. It can be 2 or 3. So for my case, it's just one box. Whichever p-values are low, those are the ones that are having an effect. So that's what we're determining. How do we know what factors are affecting how many times students go to the lab? Well, in my data, who their instructor is affects how often they go to the lab. Maybe they're getting more help from some instructors than others. The ones that don't help much, they don't really take the time to go, which is kind of understandable. So yours might be time of day. They go in the day more than the night, or vice versa, or something like that. Or it might be both. Or it might be the interaction, like certain instructors in the day or certain instructors at night or whatever. So that's what we're trying to determine. In the end, it's the p-values that are low, that are below 0.05, that are the ones that are having an effect on the data. And so there we go.